Hi there. This is a brief introduction into the Docker ecosystem. Docker is a container technology that is kind of replacing virtual machines. Let me explain. If you work for a police or an investigation company, then you might have a virtual machine with your favorite analysis tools, and you share them amongst your investigators. Maybe you have an application and several people want to use it locally. So before you created a virtual machine, you shared it, and then everyone has to get a copy. The problem is if this is a large image, multiple gigabytes of data, then keeping the image updated is a pain because a little bit everyone is a little bit adapting or changing its local copy, and then they don't want to get the master again, and they need to download it, and it's a space problem and so forth. With Docker, this is a main benefit to me is the sharing is absolutely phenomenal. So it's not only what you see on the screen that the hypervisor is running several guest OSs with, let's say, Microsoft Windows and Linux or even Mac OS X. So in the Docker engine, it's a little bit less separated as a virtual machine, but it has the advantage of having a master and syncing and sharing it amongst other clients very easily. So that's what this presentation is about. So the developer of Docker starts off with an instruction file, the so-called Docker file. The Docker file takes a base image, so from Microsoft or from, I don't know, from Linux or one of the, it's usually very small. A lot of images are based on Alpine Linux because it's very small. And by creating or running the build command, you can turn an instruction file, the Docker file, into an image. The image itself is dead. You can list it on your local computer, but it's not running yet. You can run it directly by using Docker run command or by using Docker Compose up. Docker Compose is expecting a Docker Compose YAML file that is containing all the specifics and port forwarding rules that are required by an image to run. You see that in a second. Once you have an image, you can run it many times, multiple times, and for every Docker, you get a port forward. Okay, let's say this is your development machine. You're kind of creating Docker images, and you want to share them amongst a lot of users, or even in a CI/CD environment as a continuous integration, continuous deployment environment. Then you push your local image, your newly created image, to a repository. Docker is giving free access to a so-called Docker Hub. This is a public repository, but for sure you can have your private repository as well. So in Hacking Lab, for example, we have our own Docker repository. The repository can be run by open source software. So if you push your image into the repository, you can then pull it to your, let's say, runtime environment. So in this case, the Docker environment in Europe or Docker environment in the US or wherever. So or share it amongst your users, could be users or data centers, whatever. And this pushing your image to the repo and pulling it from several locations, that's to me one of the benefits of using container technology. I do some live examples, but before I do the live examples, let me go through some use cases I just have on slides. If you want to find out existing Docker images on Docker Hub, you can type in Docker search, for example, Hacking Lab or Minio S3 bucket or Go Fish phishing framework or whatever. And the Docker daemon will list you images that are publicly available. If you want to find out what images you have locally on your computer in the live CD, you type in Docker images and we give back a list of images you have already pulled or locally created. If you want to pull such an image, let's say a Hacking Lab Alpine TTYD, you type in Docker pull Hacking Lab Alpine TTYD and the Docker daemon will then pull it from the internet. Then you have Docker images, you can list it locally. Usually, if you just download an image from the internet, you don't know on what port Docker is listening, so what the developer has chosen. Is it on port 80, 23, 22? You don't know. So by entering Docker inspect, you can check exposed ports. With the simplest way of running a Docker is the Docker run command. In this example, --rm means the Docker will be deleted after it has been executed. So when you close or shut down the Docker, every evidence will go away. -I is interactive, -p is port forwarding. You must know, or this is very important to know. So if you start the Docker on your live CD, you cannot access it from your host OS. Because it's an isolated Docker network and you need to create a port forward before you can access the Dockers from your host OS. Once you have a port forwarding created, then you can access it from your host. I will show you that in a sec. With the docker ps command, you can list currently running Dockers containers. So containers are those the running images if you wish. And with docker exec -i-t with the container ID, you can enter from your host OS a running container. From a Docker development perspective, we have a Hacking Lab exercise to train this a little bit. There's a GitHub repository where some instruction files, the so-called Docker file, you pull the GitHub repo, you change into it, and with the Docker build command, you turn the instruction file into an image file. And with the next command, Docker compose up, you will actually run the container on your current live CD. Okay, let's do some examples. So Docker, let me check. Let's say I want to do Docker images. Do I have some images local on my local computer? Images is the command. Docker images. No, I don't have. Do I have containers? Docker container ls. No, I don't have any containers yet because is for sure. If you don't have images, you don't have. It's impossible to have containers. So let's pull a public available image. Docker search Hacking Lab. And these are some example Docker images. Hacking Lab makes it available in their repository, and with the command docker pull, you can actually pull an image to your local computer. I choose this one. It's nice to see. It's a shell, a web shell, a Docker that is providing a web shell. So this takes a while. It's actually Docker images. They have a hierarchy, and so there's a base image and the next layer, next layer, next layer to save space. And if I type now Docker images, I should actually have one, the Hacking Lab TTYD. Docker containers ls container ls. Still, I do not have any containers. So let me run it without the port forwarding. Docker run -rm. I want to have it deleted after it has been run. -t e for interactive. Which one? I want to have the Hacking Lab Alpine TTY daemon. Okay, so now I have a Docker. So let me check Docker PS process list. Yes, I have a TTY. Can I request it from localhost? I should not because I do not have a port forwarding yet. Curl localhost and this port. Okay, that's what I would have expected. Can I enter the running Docker? Yes, I can by running Docker exec minus E for interactive, minus T for uh, the image. This is sorry. I must add the container ID because I can have many instances of this container. So I choose this one, and let's say I want to run bash in this container. Okay, now I am part of, or I have entered the Docker, my new Docker. Let's say if config minus A, see this is the Docker network, and can I request the Docker from localhost? There's port 7681 is running locally. I would like to use curl, but curl is not installed, but let me check. So missing command. So what we can do is, this is Alpine Linux, so apk update is updating the local repository. This is like in Debian, you would say apt update, or and now I can say apk add curl. This will add curl to my local testing Docker. And again, curl localhost. Now I should get any response from localhost, but yes, not from the external. So let me stop the Docker. Now the Docker will get terminated. Okay, and I run the Docker again with the port forwarding minus P source port outside host OS to the destination port inside. So this is the command to create a port forwarding. Okay, and here let me check. Curl from outside localhost 7681, and now I should get a response. So you can easily check from with your browser because it's a web shell. The purpose of this is a web shell. As you can see here, I am now connected to the Docker. Okay, I think this was my short Docker presentation. Of course, there are many other commands and interesting aspects of Docker. This was only the introduction and shall help you to create your first Docker image, to run it, and to know a little bit more about the commands. Thank you. Take care. Bye-bye.